What goes in, which I'll write in purple. What comes out, I'll write in green. And then tracking the carbon, which I'll do in black. Now, carbon is going to be something that comes out, so it gets a bit confusing because do I do it in green or doing it in black? I'm doing it in black, track the carbon, okay? You want to pay attention to the number of molecules, the nature of the molecule, and the function of the process I'm talking about, okay? So there are really 6 things to keep track of. The names of the molecules, what goes in, what comes out in carbon, and then function. What is the purpose of the process, okay? So those, let's say 5 things to really pay attention to with the process. Leslie will record this, and then it will go onto YouTube, and then it will go into Canvas. So you'll be able to sit and watch this as many times as you like and show your family and your kids and stuff, which is that exciting. Okay. Right, we're going to break it down into 4 processes. You've read about this in your book. First one, glycolysis. Okay, second one is the oxidation of pyruvate to acetyl-CoA. Sorry, there's no simple name for that. Krebs cycle and oxidative phosphorylation. So you've got to track 5 things in 4 processes. When you're studying, break it down into the 4 processes and then track these 5 things. Make sense? There's a strategy for doing this. Okay, there's a simple way to do this well, but there are lots of ways to do it badly. Okay, so what goes in? Glycolysis, glyco. What are we going to start with? Glucose. We're going to start with basically a simple sugar, glucose. So I'll do that in purple. So here's glucose. Glycolysis has 10 reactions. Okay. I'm going to draw arrows and stuff in random colors. So there are 10 reactions. You don't need to know the 10 reactions or the 10 intermediates. We talked about the first one. Glycolysis converts 1 molecule of glucose into 2 molecules of something called pyruvate. Don't have to know the structure. That arrow is 10 reactions. You don't have to know the individual reactions. So, what goes in? Glucose. What comes out? Pyruvate. That's already my mistake, so I'm going to put that in green. You obviously don't need to worry about these colors because you can redraw this with color pens and stuff when you get home. Okay, so that's what goes in. That's what comes out. In terms of at the end, let's think about the carbon. How many carbons in glucose? 6. Someone said over here, said a number. 6, yeah, good. I just didn't hear you, it's not wrong, I just didn't hear you. Okay, 6 carbons. There is no carbon released. There is no carbon dioxide produced in glycolysis. So, how many carbons must there be at the end? There must be 6, that's the first law of thermodynamics. But there are 2 of these molecules. So, how many carbons in each of these? 3. Okay, so 2 times 3 carbon pyruvates. Okay? There's no carbon that's produced. This whole set of reactions basically serves to do 2 things. One, there's an input of energy so that we can activate the process of glycolysis. And the second one is you oxidize the glucose. I'm already out of breath. You oxidize the glucose. This is my workout for the day. This is like anaerobic cellular respiration for me. Okay, so the point is that you're going to put some ATP in. We'll get a little bit of ATP out, but that's kind of crappy. It doesn't really count for much, but we'll document it anyway. We're going to oxidize the glucose. If we oxidize the glucose, oxidation involves loss of electrons. So electrons are going to come out. Okay, here is one of the most important points about cellular respiration. It is going to be used initially through the first 3 sets of processes. It's going to be used to make a molecule called, I'm going to get the pen colors right, this is what I hate about this. It's going to make a molecule called NADH. Okay, so we're going to get NADH out, and that means we've got to put in a molecule called NAD+. This stands for nicotinamide adenine dinucleotide. It doesn't matter. You can call it NAD+ and NADH. NADH is the reduced form of NAD+. The electrons basically come from glucose and the intermediates, and they're given to NAD+ to make NADH. So, what goes in? NADH, NAD+ goes in. Okay? NADH comes out. So how many? 2. Got to conserve matter, so you've got to balance these things. So we get out of this process 2 NADH. What is the point of NADH? This is a really critical point for this whole kind of spiel. The really critical thing is that NADH carries high energy electrons. That is its function. NADH's function is to carry high energy electrons. This is like, takes me back to when I was in the military. When my boss, my commander was telling me the mission, he would tell me twice, and I would repeat it to him, okay? So, if I repeat something many times, it's super important. Okay, NADH carries high energy electrons. We are basically going to use those electrons down there at the end. So we're going to start accumulating this molecule, okay? We put a little bit of ATP in. So what goes in is a little bit of ATP, and 2 ATP goes in. And if I break ATP down, what do I get out? ADP. ADP, 2 of them, okay? I also get a little bit of ATP out. So I get actually 4. Danger, yes. What comes out? That's green. So I get 4 ATP out of this. If I get 4 ATP out, what must I put in to make ATP? Okay, if I get ADP from hydrolyzing ATP, how do I get back to the ATP? I put in ADP, so we put in 4 ADP, okay? So that is glycolysis in a nutshell. You can break this down to 10 more complicated sets of processes, but that is a model of what glycolysis does, and it's good enough for us at this point. Biochem will make you memorize all 10 steps, totally pointless as far as I'm concerned. So, what do we get out? We get out 2 NADH, 4 ATP. That is the functional part, as well as the pyruvate. So what is the function of glycolysis? It's to make pyruvate, and it's to make a small amount of NADH and a small amount of ATP. What is my net gain of ATP here? 2, right? I got 4 out, but I put 2 in. My net gain is 2. Yeah? Make sense? It's like money goes into your bank account, money comes out and goes to the bar, and you're left with some for savings at the end. So that's what we're going to kind of put back into savings. What we're really, really interested in is this molecule. Okay, this is the point. That's what we're after. That's glycolysis. Okay, the next thing, what happens to the pyruvate? This is the second step. Pyruvate gets oxidized to a molecule called acetyl-CoA. So, this is the cytoplasm. We're going to take the pyruvate and we are going to move